Today here in the LCF school we're going to talk about amplitude modulation and an amplitude modulated transmitter, or AM, that was popular up until the 60s and early 70s when single sideband became very popular, using the Viking Ranger. This is a transmitter that was built and available in kit form for $179 in 1954. It weighed 50 pounds, a really big unit by today's standards. This was a self-contained transmitter with all the controls on the front panel that were needed for tuning, a VFO control, operated on 160 through 11 meters, and the necessary controls. Mode switch here for AM, CW, standby, adjusting the drive, selecting VFO or crystal, selecting the band, the coupling between the stages inside, tuning the final buffer, the microphone gain or modulation control, and the meter where we could meter the oscillator, buffer, grid, plate, or modulation. Give you an idea what's inside the Viking Ranger. This is all tube circuitry, made in 1954. Transistors were invented in 1947, so they weren't even in general use yet. So all tubes. Here's the big power transformer to produce the power for the high voltage and the other voltages, the two rectifiers. Here's some key and control circuitry. This box here contains the VFO, or variable frequency oscillator. It's in a box for stability and temperature control. The very big part of the AM transmitter is a modulator, and the modulator is basically an audio amplifier that produces about half the power in audio that's required over here for the transmitter tube. So there's a microphone amplifier, a couple of tubes, the power amplifiers, the interstage coupling by transformer, the final transformer, modulation transformer, coupling over to the final tube, which is a 6146, runs 65 watts of input power, or about 40 watts out here to the antenna. The inductor, a little extra inductance here for 160 meters, and underneath is a variable capacitor for tuning. A short lesson on amplitude modulation. In point A, graph A, we see a continuous wave. In graph B, we see some amplitude modulation being applied to the carrier, about 50% modulation. The same information in the upper and lower sideband. Down here in graph C, we see 100% modulation. Again, same information in the upper and lower sideband. Therefore, if we could remove one sideband and remove the carrier when we're not transmitting audio, we'd have a very efficient method of communication in terms of energy use, and that's single sideband. We don't transmit any carrier when there is no audio present, so it's very efficient compared to AM. AM is much higher quality in audio, generally speaking. Here's a look at the underside chassis of the Viking Ranger. Beautiful example of discrete component. By discrete component, we mean individual capacitors, resistors, RF chokes, transformers, variable capacitors. Every component was a discrete in itself, that is a complete self-contained unit. Let's take a closer look at a couple of components. This is also what we call point-to-point wiring, where the wire goes from one point to another. The components are wired directly from one point to another. Here's a resistor, discrete resistor, a capacitor, another capacitor, and some other capacitors down in here, and the bottom of the tube circuits. This is the bottom of the modulator unit. Here's some of the equipment that was available in 1954. Of course, we looked at the Viking Ranger, 75 watts of CW. You can stop the video if you want to read the information. We'll scan on down here. The Viking 2 with a little bigger transmitter, 180 watts of CW, 130 watts of phone. That was a very popular transmitter as well. All these were popular. Here's a little mobile unit, 60 watts mobile. AM, generated lots of heat with all the tubes and everything when you put that in your car. Up here was really the killer unit. This is a Viking kilowatt, a desk unit, ran 1,000 watts of AM or CW. And if you had single sideband, you could drive this unit with a single sideband exciter. You notice setting on top of the Johnson there is the Viking Ranger as a driver, AM CW driver for the Viking. Well, we've talked about the AM transmitters of the 50s. here a little bit with this Viking Johnson. We want to talk about modern transmitters, and not the most state-of-the-art, but a transceiver that I purchased in Dayton about 15 years ago in the mid-90s. It's an SGC 2020, and it weighs about 3.5 pounds. Transmits single sideband, upper lower sideband, and CW. Of course, it has a microprocessor, a filter, built-in DSP filter, and the microprocessor provides all sorts of keying alternatives. It runs from very low power up to about 20 to 25 watts. And what I want to tell you is that this unit at 25 watts or 20 watts is more effective than this unit. 40 watts of AM in a very crude sort of way is equivalent to about 10 watts of single sideband, the effective communication. But it's even more than that because you have the heterodyny of the carriers and so forth. So this little unit, which weighs 3.5 pounds, not only is a single sideband transmitter, CW transmitter, it's also a very fine receiver, weighs 3.5 pounds compared to this 50-pound transmitter. Now, as I said, this is not modern state-of-the-art. The modern state-of-the-art would run 100 watts, be this size, all mode, all band, from 160 to 440 megacycles, and with many more built-in features. But this will give you an example. This, by the way, is a collectible item. It's not made anymore. You can see a video of this on my YouTube channel here at lcfvideo.com. I just put a search. Hello, this is David Larson, member of the LCF group. Thank you for watching our little video.